So basically, we have our data sheet that we did, and we transferred it onto format and plotted it and showed it.
Yeah, it doesn't look like you made a vector though. What is all that? You know how to make a vector in Freemat? You got to use square brackets.
Oh, you use square brackets?
Yeah. So you can pull up Lab 1. That's a Lab 1 thing, and it'll show you how to make a plot.
Okay. So we just did that wrong.
Yeah, you can hit the up arrow and just insert the square brackets. The up arrow will bring back your previous commands. Move your hand. Just put, you know, close square bracket there and go all the way back and put an open square bracket at the beginning. Or just click right before the 10 and the 10.4.
Oh, right. On the equal sign or on the 10?
Well, what do you think? Come on.
On the 10.
Yeah. Okay. Try that. Where'd your close square bracket go?
I don't know.
Put it back. What? What? You're messing with me, aren't you?
I'm not.
Okay, good. Try that again. Did you do shift to do square brackets? Wait, I can't see your...
Is it a square or no?
I can't see. You're getting so small.
Oh, you know what? The first bracket isn't a square bracket.
It's a curly brace.
Yeah, I did the wrong one.
You bastard. No, fix it.
No.
Go use the right arrow.
Huh?
Or delete. Isaac, come on. You know what's weird is why are these things? Those are like we do for shift. The keyboard it's indicating backwards. Like these are the regular. I guess it's.
Yeah.
Why do they do that? It makes you think you have to do shift to do square brackets.
The grayed out one.
Did you pop them off and turn them upside down?
No. Look at the numbers. Like the grayed out one is when you shift. So it's
that is so stylish. Let's put them below there. That'll be completely backwards from what everybody thinks.
Okay, so that's true.
You know, everyone always has to reinvent a freaking wheel. Okay.
Wait, what did I do? It went away.
I don't know, but that's what you got to do. You got the square brackets right. Is that a question? Sorry, oops.
We're doing the sound one.
Good.
And we're confused on how to wire up the potentiometer.
Well, potentiometer has 3 wires, and you only need to connect between the middle and one of the sides.
Really?
Yeah, because then you have a variable resistor. As you turn it, you're going to pull in more and more of the resistor on the left, so that can go from 0 to 5K.
Oh.
Yeah.
Okay.
Yeah.
All right.
So
we don't even need this wire.
Look at that. You got the speaker going. You're almost there. Let's play some heavy metal. Get some saturation. They're getting close. How are you doing?
I just did the MATLAB. Wait.
Yeah, that's what you want.
Yeah, I just put everything on.
That's it. Yeah.
How do I copy paste it though?
Huh? Just say edit copy. Copy figure.
That's weird.
Yeah. So you can always use the snipping tool. There should be it should be edit copy. I don't know. This is Freemat though, huh?
No, that's MATLAB.
I mean MATLAB. Copy figure. What does copy option say? Well, you could always use the snipping tool. We'll do that. Is this a Mac? No. Beautiful. Is it doing anything? Is it playing? Can you hear it?
It's playing something?
Oh, good. Then, wait. Yeah. Now you can turn the screw and see if it gets louder.
Oh, wait.
Yeah. Oop. There we go. There we go. It's not very loud. You need a... Yeah, turn it there. Yeah. It's good. Now it's saturating. You hear that little... That's saturation. Yeah, that's where you get to the edge where it flattens out. The sine wave is actually getting flat there. That's... You can hear it. Heavy metal, classical music.
So now we can phone a friend, right?
Yeah. Or just enjoy the music.
Sure. Right.
Yeah, you could have somebody playing somebody. It's like your speakerphone, yeah. We have an external speakerphone.
Hey, Mom, it's Mark. You're speaking to the entire circuits class.
Through a circuit that Mark made.
Yeah, we hooked up we're doing op-amp circuits, and we have a speaker set up through an op-amp, so that way the phone audio goes through the speaker.
You're participating in a circuit lab.
I can't tell what you're saying because of the bad.
Can you turn up the volume more?
Here, can I?
Yeah, right now.
Can you say that again? Sorry.
Someone's typing in.
All right. Thank you, Mom.
What happened here? Yeah, now you can build a mixer if you want. I'll turn it back into an inverting output. Well, I got 10 minutes, 13. You're not very far though. You can skip the rest of those measurements for the inverting one and just do the audio if you want. Once you have the non-inverting amplifier, you can easily hook up your phone to it. Well, build a non-inverting op-amp. And then don't do all the measurements, just hook up the audio.
Let's keep going.
That's good.
It's much more fun. Vivaldi sounds really good.
How did you increase the quality?
Just turn up the volume as much as you can.
So basically, if we have
On the
a
app.
higher voltage source, we can turn this one into like a higher.
Yeah, if you had a higher voltage source, you could get more volts over there.
I didn't tap on that. Okay. The phone has a mind of its own now. This is the one I tapped on.
There we go. Oh, that's awesome. Thank you.
What did you say about skipping questions?
Don't skip the questions, but build the non-inverting op amp, and then you can just plug in the. You can just go straight to the audio circuit.
So we can come back to these questions.
Yeah, you can do those questions later.
Okay. So I have.
What would happen is you wouldn't tell the difference because it's just flipping the polarity of the signal, but since it's an AC signal, you can't tell. The ear can't tell the difference.
Okay. That's interesting. So remove the ground wire.
Yeah.
And then.
Yeah, if you want to just blow through the non-inverting op amp measurements and go straight to the audio, that's fine. You only have a few more minutes.
Yeah.
Too late? Sorry?
It's too late.
You already finished? Oh, you guys are too ahead of the game. Am I still recording? I'm not really seeing the projector thing right. I think I screwed up the meeting. Let me see. Am I recording or not? Yeah, it says pause, stop recording. I think I'm recording. I don't know what's going on anymore.
So I remove the ground wire from way in. Oh, positive way in. But
yeah, there's an error in the data sheet. Move it from V in, V plus, V plus.
Yeah, okay.
V. And then that's where you're gonna hook the source. And then that's gonna be where, if you do the phone, that's where you hook your phone.
So, but it says that ground the left side of R1.
Yeah, R1 is this resistor here. That used to go to the source, that's gonna now go to ground.
This one goes to ground?
Mm-hmm.
Oh. Right.
So this gray wire you added across there, that should go away. And what you want to do is hook this to ground. Well, now it's all mangled.
But it says they're connected to a variable voltage source. Oh, okay. Oh, yeah. This one to V plus.
That is correct.
So I was just connecting this over here.
Well, that's over here what you wanted to go. You were connecting it to here.
Oh, okay.
So, yeah. Well, there you go. Well, you get a bigger wire. Those are too short. Is that brown? What color is that one?
Which one?
Purple?
Which one is purple?
Why don't you use brown? Brown's bigger. Here, pull that out. So you want to go, so this guy has to go to ground. So actually you could just pull this thing out and connect it to there, right?
Well, that's not ground.
That is ground.
What positive going through it, right? Oh yeah, that's a reference. Yeah.
But we joined it to that one, so these are that's our reference. Yeah.
I see.
So plug the other end in to the V plus pin and pull out that ground. Is this the wait? That's your power. Yeah. There you go.
Okay, see.
There we go. You can use pliers too.
Rear side. And then, yeah, okay.
So then snag your pliers.
What do you want?
You don't have pliers in your kit.
Oh, yeah.
You pull them out. Pliers.
It should be there.
Over there. Yeah. That can be helpful.
Okay. So that's it.
Okay.
Now I have to connect the phone? No, not yet.
So now we got a mixer going.
Oh, whoops.
So you're doing a Pokemon theme song?
Which one's down? This way.
Mm-hmm.
I think, is that Mozart?
Yeah. have never
Mozart
done-
comes in clearer than Pokemon. Huh?
That's because I think it's. That's so funny.
That's very cool. Can you, how loud can the Pokemon go? Which one is Pokemon's?
This one.
Oh, that's good, yeah. Pokemon is now winning.
Oh, this song stopped.
Oh, shit, that's why. They're both at max. Can't tell what's playing. That's really cool.
Now we have an ad, so it's an ad and Pokemon.
So the question is why does the VN not equal to VP
Why is it not zero when there's saturation? Because
when there's saturation?
voltage needs to be distributed, or
Is it because what?
excess voltage needs to be distributed?
Excess voltage needs to be distributed. Well, suppose it was equal to zero. What would V out have to be? Suppose like you had -5 volts and you have a gain of 3 or -3. What would V out have to be?
Have to be the gain times,
It would have to be 15 volts, but you're only running it on 12 volts. So it can't get there. It's like a heater that can't get hot enough to make the temperature in your, like suppose it's, you're living in Antarctica, but you only have a little space heater and you want it to be 90 degrees in your room. It can't get there, right? So you're only going to be at like 30 degrees, right?
So why does that imply that VN doesn't equal
Why does that imply it?
Yeah. When there's saturation, why must VN not equal zero?
When there's saturation, why does Vn not equal to Vp? Well, there's a lot of ways of thinking about it, but I mean, if you're looking for a concept, I think it is that the output voltage can't get to where it needs to be for that condition to apply.
Okay.
Because it needs to get to plus 15, but it can't.
Okay.
And if it can't get to where it needs to be to make that value go to VP, then
VN equaling VP is contingent upon the out equaling the gain times.
yeah. And it also has to do with the, when the amplifier is in the linear range, the output is going to equal A times VP minus VN, right? The big, let's see if I can connect here again, because I lost the connection a while ago. I think it was in my presentation. So when you're in the linear range of the op amp, then the output is going to be A times VP minus VM. Remember the model of the op amp? Inside that op amp, there's a dependent voltage source that equals, the output equals A times VP minus VN, right? And when you're in the linear range, that's true. And it can, when that condition applies, then the feedback will be able to correct the difference between VP minus VN, because A is so large, it's going to adjust to whatever it needs to make that happen.
Right.
But it has to be able to get to a pretty big value sometimes, and sometimes it can't get that high in reality. The physics of the circuit won't allow it to get to the value it needs to, and so the output is no longer A times VP minus VN. It's hit the hard limit of that thing. And so at that point, it voids the whole model that we were working with. That model doesn't apply anymore.
Right. Okay. Why wasn't the saturation, the saturation like 10 volts-ish? But when I measured the end, got up to 12.
Yeah, I got up to 11.1 on somebody's, and that's because so the question is, why didn't it go to 12.3 or something, right? Well, the model of an op amp, or the circuit inside an op amp, is a transistor network. It's a bunch of transistors. And remember when you did that experiment with diodes and you measured the voltage drop across the diode, at what voltage it turned on was like around 0.7 volts or so? Do you remember that? The diode, the transfer function for a diode was something like, let me draw it real fast in paint. The current, which is on the vertical axis, as a function of voltage, it looks something like this. You plotted this, right? It looked like an exponential curve. Oops, but the knee of the curve happened at a particular turn-on voltage for the diode. And that was something like about 0.7 volts.
Okay.
Well, that is the voltage that you need for the PN junction to actually start having current flowing. And if you go past that, it's not going to have any current. It's not going to act right. So when you look at this diagram, when an engineer looks at this, they see, V plus is right here. But if you look at the output, there's a diode drop from this Q14 transistor to get to the output voltage. So that's a minimum voltage drop of 0.7 from the rails. You see that? Well, V plus is 12 volts, and you've got a diode drop here that current has to flow through. That diode drop is going to keep you at least a 0.7 volt drop here from that diode, that junction, the PN junction inside the transistor, which I call a diode drop, but it's actually part of the transistor, because the transistor is an NPN sandwich.
Right.
And so that means the most you can get, the highest you can get at this point here is going to be 0.7 volts below your voltage of V plus.
Their internal thing whatever that voltage that limits how.
Yeah. And if you want more range, as Han was pointing out, you could actually run this thing at 20 volts. You can run these things up to like some maximum value. The 741 is a pretty broad range. It'll always be some number below your power supply voltage. Yeah. Yeah.